This is page 75, your warm-up for the quiz that we're taking today. And we're going to start with a heat of reaction problem. So it's got three parts, A, B, and C. Part A says use the heats of formation in the chart to determine the heat of the reaction. Remember, heat of reaction, this is when we do products minus reactants to find the answer. Okay, so the products are the part after the arrow. The reactants are the part before the arrow. So if we're doing products minus reactants, we're going to end up doing 5 CO2 plus 6 water. Those are our products. We add those up. Then we separately subtract the C5H12 and the 8 oxygen after we add those up. You find your totals first. Remember your order of operations. Find your totals first. Then after you have the total in this parentheses and the total in that parentheses, you do the parentheses first, then you subtract. So for 5 CO2, that 5 means we are multiplying 5 times the number for CO2 that is in the chart, which is negative 394. So I'm doing 5 times negative 394. Then I'm doing plus 6 water, so that is 6 times the number for water that is in the chart, negative 286. Then I have to subtract C5H12. That's negative 146 in the chart. And it says plus 8 oxygen. So I'm doing 8 times the number for oxygen. And I run into a little bit of a problem here, which is that oxygen is not in the chart. But we know that oxygen, as it's written here, is an element by itself. And when you have an element by itself, as we learned back on page 70,
0.
Its heat of formation will be 0. So I'm going to plug in 0 for oxygen. Again, remembering order of operations, that 8 times 0 is going to happen first before you add it to the negative 146. So overall, 8 times 0, you're just adding 0 to the negative 146 for that second set of parentheses. So that one's really easy to simplify. This first one, I advise you to just stick that in your calculator, but make sure you're not missing any negative signs. Again, that's the main place where people mess up on this, is they forget a negative sign or they typo it and miss a negative sign in their calculator. But if you put this in your parentheses correctly without missing a negative sign, then you're going to get this right here. So now we just subtract our 2 simplified sets of parentheses. And again, I'll say it again, when you subtract, be careful not to miss a negative sign. For your final answer for part A, you get negative 3,540. And the units on that should be KJ, kilojoules. The units on that should be kilojoules. Part B says to predict if it's endo or exothermic and if heat is absorbed or released. How do you tell, what do you look at with this number to know if it's endo or exothermic?
If it's exo, that means it's positive, and exo.
Check if it's positive or negative. If it's positive, it will be endothermic. If it's negative, it will be exothermic. And this problem on the warm-up, we have a negative number, so that's going to be exothermic. And if it's exothermic, is heat absorbed or released? It is released. Okay, for step C, the first thing you need to do is copy down the reaction exactly the way they typed it. And I advise you to copy it directly under, because you want to have some empty space on the left and on the right. So I advise you to just directly under where they typed it, copy down just exactly what they typed. Okay, directly under, just copy exactly what they typed. You don't have to use your brain for it at all. You're just copying exactly what they typed. Okay, and that's one of those things you can do immediately when you start your quiz. When I say flip it over, put your name on it, and begin, the first thing you can do is just copy that equation directly down in part C. The other thing we have to do, because part C wants us to write the thermochemical equation, which has both the reaction and the amount of heat change included in it, we have to put that heat change in the reaction, and depending on if it's endo or exothermic, it should go on a particular side. If it's going to go on the left side, on the reactant side, do we do that on the reactant side when it's endothermic or when it's exothermic? That's where it goes when it's endothermic, because endothermic means the heat's going in at the beginning, so we would put it in at the beginning. Exothermic means the heat's getting released, so we got to put that heat at the end, and the product side, so it's coming out at the end of the reaction. Now the trick to this is that it was negative when we calculated it independently. When you put it on the product side, you have to add it. Okay, and that's because the negative here is telling you put it on the product side. When you put it in the reaction, it has to be added. You cannot subtract in part C at all. If you put a minus sign in part C anywhere, it's definitely wrong. Okay, you cannot put minus signs anywhere in part C. It's got to be added. So you just have to pick the correct side, left or right, and then add it. No matter which side you put it on, you add it. So this negative sign tells me that it goes on the product side, because that tells me it's exothermic, it goes at the end, but you still have to flip it to positive before you write it in. How you doing so far? Cool. Do you have questions so far? Okay, let's keep going. Number 2 says a phase change from liquid to solid is endo or exothermic. Heat is being absorbed or released. Liquid to solid, that's a little process that we call freezing. Think about it this way. If you're going to freeze some water, do you put it on the stove or in the fridge?
Fridge.
In the fridge. So are you putting heat in or taking heat out?
Taking heat out.
If you put it in the fridge, you're trying to take heat out, which means is that endo or exothermic? Exothermic, so heat needs to be absorbed or released? Released. Okay, number 3, a phase change from liquid to gas. That's a little thing that we call vaporization. Or, another way to think of it is basically it's boiling. If you're going to boil water, do you put it in the fridge or on the stove?
So,
You put it on the stove. So are you adding heat or taking heat away?
adding
Adding heat. That's going to be
endo.
endothermic when you add heat, and heat will be absorbed. Okay, number 4, if the surroundings cool down, then what kind of process is it? Think of it with our little drawings we've been doing. You got a beaker or a test tube. You are on the outside going, hey, it's cold. If you're on the outside and it feels cold, does that mean that the beaker is pushing heat out onto you, or is it taking your heat from you? If it feels cold to you, it is taking your heat. So heat's going in to that beaker, and that means that the beaker has a endothermic process going on. And heat is being absorbed. Number 5 says if the surroundings heat up, so you, part of the surroundings, are touching a beaker and you're like, oh man, it's hot. Does that mean that there's heat coming out toward you, or that your heat is going in? If it feels hot to you, then heat is coming out toward you. So for the beaker, that means it's exothermic. The heat's leaving. It's being released. For the heating curve, it pretty much comes down to if you just know that this is solid, liquid, and gas, and if you know some vocabulary, you can probably figure the rest out from there. Where does vaporization and condensation happen?
In between liquid and gas.
It happens at 4, which is between liquid and gas. Where is it both solid and liquid?
3.
Well, 3 is only liquid.
2.
1 is only solid, so 2 is both solid and liquid. Where is it liquid only?
3.
3. Where's the lowest energy? At 1 where the solids are. And solid only is 1, gas only is 5. Liquid and gas together are 4 between the liquid and the gas. Where's the highest energy? 5 gases. And freezing and melting happens. 1 is just solid. Freezing and melting has to happen between solid and liquid, so that's part 2.